Guys, welcome back to the physics book. Today we are going to start with a new chapter, sound, and these are the list of topics that we are going to discuss today. Of which first is what is meant by sound, what is the difference between sound and light, what is meant by vibration, reverberations, echo, resonance, Doppler effect, what is meant by natural frequency, and application of the echo. So to start with, what is sound? So sound is nothing but a form of energy. So I will just jot down the important key points. What is meant by sound? So it's a form of energy which causes disturbance in the medium in the form of pressure waves and that propagates away from the source. So these are like this is four. So these are the four key points which characterizes what is a sound. So sound is nothing but an energy. We all know that everything in this universe is comprised of some energy, and sound is also a form of energy which causes disturbance in the medium, and it's in the form of pressure waves that propagates away from the source. Let's take an example to discuss this, and there is one fifth point which is very important. This is a longitudinal wave. And this is very important, might be asked as a one mark question. So now let's understand the definition of sound, whatever the key characteristic points that we have mentioned, with an example. So let's take a speaker to some system. Okay, so what will happen? So this is a speaker, this is a source of sound, and this is surrounded by air. Air is the medium, and somebody is standing like away from this speaker. So now sound is a form of energy. So what will happen is you are giving an electrical energy to this speaker, and the part of this electrical energy is getting converted into sound energy. So this is a form of energy, and what that energy does is, here your speaker is surrounded by air, and what this energy that is getting converted from electrical energy to the sound energy, what it does is it will just disturb the air present in this near the speaker. So what will happen? Let me just divide this air column into 4 or 5 segments. Okay, so just this is an imaginary division we are just doing to make you understand. So this is 1, this is 2, this is 3, this is 4. So what will happen to the air that is nearby this speaker? It will start to compress, and slowly this compression will reduce. It will be like this. Okay, now you can pictorially see that here the compression is more, and slowly as you move away from the speaker, the compression is slowly getting reduced. So what will happen is, if this person is standing closer to the speaker, the compression will be more and he will be hearing more sound. As he slowly moves away from the speaker, the compression is less and he will hear less sound. So now going back to the definition, sound is a form of energy, correct? Yes. You are supplying electrical energy, and part of the electrical energy is converted into sound energy, which is causing a disturbance in the medium, which is nothing but the air. That disturbance is in the form of compression and rarefaction. So whenever air is getting compressed, some other part of the air should undergo rarefaction. So this is like a compression and rarefaction happening as a disturbance in the medium due to this sound energy. And why this is called as a pressure waves is same reason as the compression and rarefaction. As the air is getting compressed, it is pressurizing the air, and that is why it is called as a pressure waves. It's more technical than this, but as per ICSE 10th, it should be sufficient to understand that as compression and rarefaction is happening, it is pressurizing the air and depressurizing air in some part. So it is called pressure waves. And you can see that this sound wave is propagating away from, why I'm not going to draw in this way is, sound is not a transverse wave. So we will discuss that later. So as the fourth point, the sound propagates away from the source. Yes, sound always propagates away from the source, and as the distance from the source increases, the sound also slowly diminishes because the compression is slowly getting diminished. And why it is a longitudinal waves is that it's very obvious that compression, rarefaction, and pressure waves are involved, and it's a longitudinal waves. Transverse waves means you would be having a waves like this. So now we know that what is meant by sound. The second important thing is what is the difference between sound and light. So there is a primary difference between sound and light, which is very, very critical to understand what is sound and what is light. First thing is sound needs a medium to propagate. We just saw an example that speaker is emitting sound waves and it needs a medium, that is air, to reach the person who is hearing the sound. So that is why sound needs medium. Example, you can just see speaker. Whereas if you go for light energy to travel, it doesn't require any medium. No medium required. A simple example, you can think of our universe where sun is emitting radiations in the form of light and heat, and that light energy doesn't require any medium. It is falling on earth directly through vacuum. And the next thing is, when you go to sound, it is a longitudinal wave. That is, it is a pressure wave. Pressure wave is nothing but in the medium in which the sound wave is propagating, it will undergo compression and rarefaction of the medium. So that is why it is called pressure waves. Whereas light is a transverse waves. So here the wave pattern will be like, it will be compressed. Slowly the compression will increase. The compression will diminish. Here the air, this is closer to the source. Or I will just simply mention this as source. So nearer the source, the compression will be more, and as we move away from the source, the compression is slowly diminishing. The closer he is, he will hear more sound. The farther he is, he will hear less sound. Transverse wave, on the other hand, that is the light, it will travel in this fashion. It's like an oscillatory motion with respect to an equilibrium point, and this is the equilibrium point. This is because of oscillation of photon. What is meant by vibration? So for this vibration, let's take a tuning fork. This is an best and easy to understand example. This is a tuning fork. When somebody is trying to hit this tuning fork, it will oscillate. It will move back and forth. And this is like, I'm just hitting this with a hammer or a mallet. And this tuning fork starts to vibrate. So what is this vibration? Vibration is nothing but, as we characterize the sound, we will characterize vibration also. Vibration is nothing but a to and fro motion of a material. Material as in whichever is you are saying that it is vibrating, so that material. So to and fro motion of a material, and the material is nothing but tuning fork in this case. And you can say this is a mechanical motion. You can see this to and fro motion is a mechanical motion about its mean position. So what is meant by vibration? Vibration is the to and fro motion of a material, to and fro motion of this tuning fork, which is nothing but a mechanical motion about its mean position. Mean position is this, which is like the position which it was having when it was not hit by a hammer or a mallet. That is its equilibrium position when it is not applied with any external force. So now we saw what is meant by vibration of a body. Now before moving to this reverberation and echo, we just need to understand one key point. What is meant by reflection of sound? Does sound reflects? So let's assume there is a sound wave that is coming from a speaker. This is emitting some sound, and you are having a wall here. So what happens is this wall will reflect the sound waves. Yes, sound waves is capable of being reflected. So this wall will reflect the sound waves, but it will not reflect like whatever, say for example, E amount of sound energy is coming here, but it will absorb some amount, for example, delta E. amount of energy of sound energy will be absorbed in this wall, and the remaining E minus delta E will be reflected by the wall. If the surface is very smooth, where the sound wave hits smooth, then if it is smooth, then the amount of reflected sound waves will be more. Smooth means more waves, more reflection. If the surface is very hard, or sorry, I should not say hard, it is very rough or coarse, then less reflection. So coarse surface. Now we need to understand what is meant by persistence of hearing or persistence of sound. Okay. So it is said that human ear can persist the sound even after the source of the sound is removed for 0.1 seconds. So what does this mean? So this is 0.1 second is called the persistence of hearing. The unit is in seconds. So how I can understand this? Let's take a speaker, and this speaker is in a temple. Let's assume this is a temple speaker, and it exactly starts at 5 a.m. in the morning. It is emitting some sound, and your house is nearby, and you are listening to this sound at 5 a.m. Leaving about the time difference, like start of the sound to till when you hear, leave about that. Let's assume you are very close to this speaker, and this temple speaker starts the sound at 5 a.m. and you are hearing that at 5 a.m. neglecting the distance. Let's assume that you are very close to the speaker. So now what happens is they are stopping the speaker at 5:30 a.m. Okay, but the 5:30 it will not stop at 5:30 a.m. for you, but it will be stopping at 5:30. If you include seconds as well, I will just include seconds as well. This is 5 hours 00 minutes 00 seconds in the morning, and they are stopping this at 5:30 a.m. in the morning. Okay, same case here. You are listening this at 5 a.m. in the morning, and they have stopped it at 5:30 a.m. But you will listen this till 5:30 0.1, which means a.m. Which means though the sound stopped at 5:30 a.m., you are listening this sound for additional 0.1 second. So whatever the sound has reached your ear at 5:30 a.m., you will still be able to hear that sound for extra additional 0.1 second. So that is what is called persistence of hearing. It plays vital role in understanding reverberation and echo.